Um, Hello everyone, my name is Camilo and I work at Klarna. I'm going to talk about some of the things that we have done continuous delivery by using Docker and Jenkins mostly. And this talk was previously offered in MuCon, Microsoft's conference. Anyone here was there besides the Klarna guys? Yeah, no. Yeah, and it was meant to introduce Docker and Jenkins, so if you have a lot of experience with Docker, it might be a bit boring, but I will try to make it at least fun. For the one that don't know me, that's pretty much everybody, I guess. My name is Camilo Ribeiro. I'm Brazilian, and I work at Klarna as a software engineer, mostly doing testing and DevOps, which in my opinion is kind of the same thing. And I'm a former consultant for ThoughtWorks in Brazil and San Francisco. So how many of you never tried Docker before? Are completely new to Docker? Yeah, good. So you have the chance tonight to download the repository here and try some and see how it works. And how many of you never tried the Jenkins job DSL? That's a way to automate job DSL, to automate the jobs. So you have the opportunity to try it as well and give me feedback, of course. Thank you. So yes, this is the repository. You just go there and you run one command, and then you have a Jenkins, and you can see it works, and you can change it by yourself. So yes, we're going to talk about continuous delivery pipeline, and for the ones that are not familiar with the concept, is the concept of reducing risks by having several steps where you promote some application from a brand new application to an application that you can ship, and then you can deploy to production whenever you want to do that. And you do that by basically having different steps where you can get an application and expose it to a kind of testing or some kind of build where you will increase the confiability of having it in production over time. And for doing that, we have several tools. To mention some, you have TeamCity, that I know a lot of people in Spotify use. You have ThoughtWorks Go, that the guys from ThoughtWorks use. You have Travis, that open source people use. And you have Jenkins, that's like pretty much everybody else that wants to have continuous delivery pipeline can use. But all of them are good in many ways. And we choose to use Jenkins for some reasons, and I'm going to explain why. The first one is that Jenkins is used by a lot of people out there, and a lot of people contribute, and they add their own spices to Jenkins. So if you want to have something that's really reliable and it's very, you can customize a lot in many ways, Jenkins is really nice. And also, it's easier when you hire someone that they have previous experience with Jenkins, or if you migrate from one company to the other, it's very likely that you have Jenkins in some teams at least there. And the second reason, it might be my influence on the first one, is that Jenkins has support to many, many tools, proprietary and open source tools. So you can use Jenkins with Slack, you can use Jenkins with Stash, with GitHub, with Docker, and like you can send emails, you can do a lot of stuff with Jenkins. It's very powerful. And the third reason, and very important one, is that Jenkins is highly you can automatize it very easily, and that's what we are going to talk tonight about Jenkins. But when you're never tried Jenkins before, and then you go and install it and you search for how to use Jenkins, you get more or less a picture like that. That is like Jenkins, that you go there through the UI and you change everything, and then you're happy, nice. Now I need to have, I need to run and build some stuff on top of Java. Then you have to go there, create a Jenkins agent, and install Java and install everything. But then you work in a company with a lot of microservices, and some of them are built in Erlang. Then you have to go there and create a new one and start using labels. And that works very well, but sometimes it's just annoying because you want to try 3 different versions of Ruby, for example, and then you have to go and create slaves or agents with different versions of Ruby, or you have to use some tools to configure it, like Chef, Puppet, and Ansible. Yeah. So we found 2 problems. One of them we just discussed a bit about. It's like how to configure it, and there are many ways to configure it. Like if you use Chef, or if you use shell script or whatever you want to use. But even though it's kind of hard, and eventually you have to go to the internet, download stuff, and it might not be available anymore. So you have to spend a lot of work doing that. And the other problem is that Jenkins is a kind of senior tool, right? That's a nice word for old. And and it used that thing that everybody here loves. That's XML. So if you want to keep track of your Jenkins, you either have a copy of it, like, come on, it doesn't fit the 21st century, right? Copy files and everything. Or you can use Git and control XML. What's not very nice and pleasant as well. So then we choose 2 tools to take care of those 2 problems. And one of them is the hottest tool ever in the last months, Docker. And yeah, I'm quite sure that everybody here knows Docker, but let's just remember that you can have an infrastructure, and then you have a single operating system, and then you provide a Docker engine, and then for each one of the containers that you run, you have your application and your libs there. So if you think about, if you compare it with virtual machines, in virtual machines you used to have abstraction of hardware, and with Docker now you have operating system abstraction as well. So you don't have to care about creating operating systems to run applications. You just run the application and you share whatever operating system it needs. And it gives you a lot of power. Like you can run a lot of different things on Docker. So you can run different operating systems, you can run different servers, you can run different program languages, databases. You can even run Docker in Docker. And then you can have a Dockerception. Like you can have several Dockers inside Dockers, and it gets slower as well. You can have Linux containers, pretty much everything, and it's really cool and powerful. And how it works, so you have a common repository out there that's called hub.docker.com, but you can also have hub.yourcompany.com, where you can have your private containers, images, and then you just ship it there, and whenever you need, you just get it from there. And how hard it is? Well, it's pretty much as hard as this 2 lines. And if you don't use the first one, implicitly run it's in the second one. So I'm just being verbose here. So you basically need to run something that uses Gradle. You get an image that has Gradle. Of course, you have to share your application with that image. And then you run it, and done. So you have it working. But then you need to run Ruby, and then you do the same thing. You get an image that runs Ruby, and you run the command that you want to run, and you don't affect your operating system or anything. So you basically have a clean state all the time. It's quite great. And then you need to run Node, or even you need to run an entire application that might have database and stuff, and you can run it like this. For example, Jenkins can be run on Docker just by exposing a port or something. Or you want to run just a Git command, then you just do this. So it's pretty nice, but it's not enough. Like if you think about testing, one of the hardest things is to get the environment for an application level itself. It's very hard. It's very like you spend a lot of time building images and creating all the configuration that you need and all the servers and everything. And all you want is to have an application to test it in your local machine. So Docker has some plugins, and one of them that I like a lot is Docker Compose that were mentioned before here. And in my own words, and I may pay the price later when someone comes to me and say, hey, you know, it's not like this, but it gives you like a cloudish power to run in your local machine. And that's very nice. So you can have your entire of course, if it's not huge, you can have your entire microservices architecture in your machine, and then you can run tests and you can check logs from one to the other. You can do a lot of stuff. And how hard it is? Well, it is as hard as defining a file where you have the name of the servers that you want, the services that you want to run, what ports you want to expose to the outside world, the links that you want to have. So in this example, we are representing that other picture that we showed previously. So we have an Nginx server running, proxying 3 Docker containers running drop wizard application, consuming a MongoDB database. And you can run it in your local, and you can do the tests. And if you have a front end, you can just connect it to it there, and it's really cool. And then a lot of time ago, in the Middle Ages, a very smart guy that liked Docker as well, he built a single unit, and his name was Sauron. And he built a Docker image, and he said that he will use one image to run them all. And in this image, he had 2 things. He had a Docker running and a Docker compose. And that's how we solved a lot of problems on testing, and especially when it comes to integration tests, when we have to change different configurations on different microservices. So I want to test the microservice A, integrating with the microservice B in production, and the latest version that they have available now. That's the candidate that's going to be released at any point in the future. Maybe in 1 hour, maybe tomorrow. So you want to know that it's working there. And just remember, the infrastructure can be anything. It can be your local machine, it can be a data center of your own, or it can be like different providers like Amazon or Rackspace or whatever. But then we fixed half of the problem that you used to have. Now we start having like a really nice Docker agents that we could use to run all the microservices that we had. But every time I had to change something on Jenkins, it was still a bit painful. And for the ones that don't know Jenkins, I'm going to give you a free sample now. So you go to a job, and then you click on the job, and then it's going to open this page, and you click on configure. When you click on configure, you have a big form, and then you have to change a lot of stuff there. And when you change this, then you click on the save button, and then you do it, and you have it done. So why are you complaining? It's so simple. Yeah, it's simple, but then, well, eventually it grows. And imagine you doing this for 90 different jobs, and it's a real life example. Maybe not the babe, but it was me. But the babe's more beautiful than me then. That's okay. So then we start looking on how to automate Jenkins itself. Is it easy? Is it hard? And then we found out 4 different ways to do that. There are very more. Template project plugins, so you can have templates. And when I hear templates, I just get a bit nervous. Let's just skip this one. And then you have the job generator plugin. A generator is also a word that's, yeah. The job builder sounds great, but then we found out that it's XML. And then the job, oh no, you can use JSON as well. That's like XML for hipsters. But then we have the job DSL, and the DSL is a really nice thing, right? Like everybody loves DSLs, but that's not the reason. The reason is that besides the DSL, we also have grooving behind. So it means that everything that you can do with Groovy, you can do with your Jenkins job DSL. And I'm going to show you a really simple example of how it works. This is an example. So you have the job, the description, the source code management, and the steps. And when you run the job DSL, it transforms this beautiful small thing in huge XML, and I replaced a lot of code here with the dots. As you can see, it used to be a bit like 5 times bigger than that, but this is what actually matters for us. But if you remove one of those lines, it's probably going to break Jenkins. So we don't really want to get that in that level. Here, a bit more complex example to show how it reflects in the GUI. So the first line there, it's basically going to create a job with a name and nothing else. The second line, it's called SCM, and it stands for Source Code Management. And then you have a Git plugin and URL. So as you can see here, if you know Jenkins already, if you're using Jenkins today, to migrate to a job DSL, it's very easy because the names are exactly the same. The guys were really good and great on building this thing here. And triggers the same thing. So you have triggers, you have pull SCM, and then the schedule there, and the steps, and then you have shell commands, and then you just add the new command, and they do it in the same order as you have, so you can keep track of the order as you please. And if you want to have a publisher with a report, it's just to show that like the Cucumber, the HTML report, it's a plugin that you install in Jenkins, and they also have support to several of the plugins that I have on Jenkins. So it's really nice. But then we start using this, and even though it was a bit hard to maintain because, well, it kept growing, right? So you have a lot, instead of going to the UI and changing in a lot of different pages, you have to go to a bunch of different files in Groovy and change it there. And we had the idea of turning it to a project, and then we had some advantages. The first one, and the one that I like the most, is that you can test it. If I have code, I should have tests, right? That's the rule number one. And then with this with a like a Gradle project, we can have tests and we can run it, and we can, well, it's not very beautiful, but it kind of does the job. And you can just check if your pipeline is okay before you actually run it and change the pipeline. And this is how it looks like if you use Spock. That's a really cool tool that runs on Groovy. How many of you have tried Spock? Yeah, it's great, right? I like it. But you can use whatever tool you want to use to test it, whatever framework you want to use. Another thing that's nice is that if you're using IDE like IntelliJ, you will have the option to do the autocomplete thing. That seems to be a big thing for Java developers, and I like it too. And of course, you can redefine the DSL if you want to. So if the DSL is not hipster enough for you, you can just go there and create your own, or something that fits to your team. But actually, I have another good reason for that. So imagine that you have a create job method that's going to create a job for you and return a job for you, and you want to change all your jobs at the same time. So you just change it once, and then the job's done. It's really good. And the other reason is that you can test your pipeline. It's kind of a meta testing because the pipeline is what's going to test your project, right? But then you just make sure that it's working before you update it, as we discussed before. And it doesn't necessarily need to be in the same pipeline, but if you're using it, it could be used in the same pipeline. So your update job tests itself, and then if it works, it runs the job DSL and rebuilds the pipeline for you. And that's how we moved from manual Jenkins, where you have to go to the GUI and change everything, to and like well-labeled, defined Jenkins agents, where you had to choose and wait for the next Java agent to be free to run, to super cool Jenkins. And actually, there's a new version of Jenkins in his T-shirt there. That's a Jedi, and it will be replaced by the Jedi Jenkins. That runs everything basically that if you're not doing Microsoft services. Two concrete examples that we had at Klarna that for this pipeline is that I work in a team, in the checkout team, and we used to run 4 microservices. I mean, a fat service and 3 microservices. We had to start. No, sorry. Yeah, the 4 microservices and then we had a new one. So I just solved the data, but that's pretty much the same thing that we presented inside Klarna. And adding a new pipeline for the new microservices, and of course we follow a lot of conventions. So to build a job, it's Gradle build. To test the job, it's Gradle test. And then we follow a lot of conventions for the service level tests, performance tests, and everything. So it was as hard as adding this last line, the application 5 new app, to create a new pipeline with all the tests that we have and all the deployment that we have, uh, based only on the name of the app and in the name of the repository. And it was really cool because if we had to think about the pipeline now again and create all the scripts like AWS scripts, Gradle scripts, tests, and configure the Jenkins manually and everything, it would take at least like 3 days to have everything in place, plus testing and monitoring and everything. And with this, we, of course, like we still tested and monitored everything to check that it was all right, but we saved the time of creating everything through the GUI. That's what no one wants to do, actually, because we are pretty lazy sometimes. And then we had this other part, that's the 90 jobs that we discussed before. Well, we got a very angry call from someone in the support for engineering there, saying, guys, you were like with this terabytes of logs in your Jenkins, what's happening? And then we realized we never ever removed any log from Jenkins. And yeah, it's pretty good reason to get pissed off if you work in the like IT department, right? So we went there and we created this line and that method, and we had the log rotation, saving only the 10 less jobs because the data that's sensitive and we need to keep track of, we send to other things like Elk, Kafka, or wherever, I don't know. And everything else we just throw out. And it was as easy as this. Next time at each one of the jobs runs, it would clean all the mess that they had before. So if you want to learn more, you're very welcome to check out the project CDeasy. It stands for Continuous Delivery Made Easy. But I'm very clear that it's just an example and you should not use it commercially because it's probably going to break. But you can try it and get inspired and then change your own continuous delivery pipeline or start it if you don't have one yet. There's the job DSL playground as well, where you can get a really beautiful DSL script that's a very simple one, and you can see how ugly it's going to be when you run it. But also it's very useful because you check if it's working or not. And the last one is the API reference. That's really good. You can go there and you check in which context it's running. And now we are trying to have a demo. I didn't have a lot of luck before because of internet connection. So I'm going to be a bit selfish now, and I'm going to ask if you're using the internet from the guest, if you can turn it off just for a few minutes, then I think that's going to work. Yeah, this is the, oops. Oh, I need someone that understands of computers here. Mirror. So yeah, so this is the repository. And this is kind of the new way of GitHub to show the repository if you don't have it yet. I like it. And this is a Docker container running on top of a Jenkins running on top of Docker compose file. And now I'm going to run this guy here. And what this guy is going to do is basically reach out the same repository and run a folder called and run the Groovy scripts. So before it's going to test everything and see if it's working, and then it's going to run the plugin that actually go there and do all the magic behind the scenes. And let's see if we are lucky today. Seems to work. Yeah. So everything runs on Docker since we don't have anything else installed in the computer. It's going to download, to pull a machine that I pulled already to save some 3 minutes from everybody. And then it's going to download all the Java dependencies that's required because this computer never exists before, since it's a pretty brand new Docker image and it's going to emulate a container and it's going to just disappear after finishing. So it doesn't matter how many times I run, it's never going to cache this unless if you have some ugly sharing thing, and that's not the goal here. But anyway, it's running it, and it run the test, and now it's building all the scripts that we had there. So if I go back to the home page in Jenkins, now I have a lot of jobs here. And if I go to the pipeline, I have nothing yet because I never run the pipeline. But the first time that I run my unit tests, that's the first job in my pipeline, run. Then I have a pipeline. This plugin is called pipeline delivery pipeline, and it basically gets the connections between your jobs using parameterized trigger and trigger and dependencies and all of those commands that you can have in the jobs, and it connects them with this beautiful HTML. Interesting, like in this example of the pipeline, right here, after kind of promoting RPM, we are going to run those guys in parallel. So, and you can do that using the job pipeline. So you can have, for example, the load test running at the same time as a service level test or integration test or everything. And only if all the jobs are green, it's going to call the next one that's like promote to stage. So you can have your pipeline and increase the confidence of your deliverable over time. And that's really cool and slow. Those jobs are actually empty. They only have a wait from 5 to 10 seconds, just to give this impression that something is going on. But the goal is more like to show how you can build the pipeline itself and have some fun. So we also have some kind of language agnostic jobs here. That's just to show that if you want to run, for example, Ruby and Java at the same time, you can do that. So each one's going to get a build executor, and and then if I click here in the Ruby one, it's pulling the version. I already pulled it just to save time, and it's running a project called Ice Cream, just to run the tests and check if it's working. So it's exactly the same machine. It has nothing else but Docker, so you can run it, and then if you have a Java application but you prefer to do your tests in Ruby, you can do, you can have 2 containers that talk to each other, one with Ruby, one with Java, install application 1, run the test on the other one. Or if you want to run Erlang, the same thing. If you want to run, if you want to check your configuration for load balancers and stuff, it's the same thing. So I hope we have some 2 minutes for questions. Yes? No? Okay, good. And then we check how it runs. Questions? No? Oh, sorry. Well, I myself never tried Docker in production. Not only because I don't take this kind of decisions. I'm more like the guy behind what happens before production, but also because my team didn't want to use it yet. Well, that's the pipeline itself. I mean, it runs in production actually. Sorry, but the production for the pipeline is internal environment, and then um, well, we just have Docker. Sorry, a physical virtual-ish machine that runs Jenkins. It's not a Docker container, but then we have like different machines, and in each one of the machines, we only have Docker installed. So it's exactly like this. We don't have a bunch of containers that just talk to each other. That's the next stage, and I really want to do that, and we are thinking how to do that. But so far, what we have is a robust machine running Jenkins and a lot of Docker agents. So if, for example, if I want to change, if I want to run a lot more jobs per day, then I just create more Docker, I just instantiate more machines with Docker, and it's pretty much it. Yeah, I mean, what we do is basically that. Yeah, now I have it. So I have a beautiful report here, and I'm sorry, but like it's because it's like the gateway for production. So in the last step here, I forgot to mention it, and that's actually what we have. We have this deploy to production here, and when you click here, then you run the job. So you can decide if you're going to have continuous delivery with or without continuous deployment. And I'm a big fan of not having continuous deployment, because well, it doesn't matter how you trust in your testing and your infrastructure and everything. Murph is always there. So I'm pretty much like Black Friday not deploying unless I have a really good reason. Huh? Sorry? Yeah, but not in Black Friday. Sorry. Yeah, we use this to deploy to production. We just don't deploy our services today. My team, right? But we have 40 different teams in Klarna, and many of them are using containers. Many of them are using other things, and I'm from one team that use other things. And we basically deploy in one of the jobs here, but we deploy to real virtual machines. Real virtual machines is really great. Any other questions? Yes. Um, it depends a lot. Like we use Docker Compose, and one of the problems, maybe because I'm doing something wrong, I have some containers that only run tests, and other containers they will run like the application itself. So when I do a Docker run or a Docker Compose run or a Docker Compose up, what happens is that my first container, that the one that has all the dependencies, it's a short-living container, so it should run the job, exit 0, and die, but it doesn't kill all the others. I don't know why. Maybe someone here knows why. I can explain in detail if you probably know how to fix it. But then eventually I have some Docker containers running, and I just go there in the last step in my Jenkins, and I do a Docker Compose stop in all of them. But we don't clean any data, because the only data that we share is data that we are going to show in the report here. So for example, in the unit test job, I would share a volume between my container and my local machine, and then I would expose this guy to Jenkins. And after that, I really don't care what happens there, because I already have it saved. And after 10 builds, it's going to disappear anyway. So I don't care about what data Docker gives me back, unless if it's some sensitive data, then I push it to another repository of data, like that's a database or something. But I don't keep it. Any other question? So yeah, there was the question thing. I would like to thank you all for being here tonight. Thank you.